The wild seas that lash Australia's southern coast are driven by the roaring 40s, the mighty winds that race all the way around the globe at these latitudes. Their surging power brings food and oxygen to sustain a marvelous array of plants and animals which flourishes in these southern waters. The force of the wind and sea shapes the nature of Australia's marine life and carves the wild splendor of the continent's southern edge. That force is generated a long way to the south, 2,000 kilometers away in the Antarctic. What happens here in this icy wilderness sets the pattern for just about everything that happens in the seas surrounding Australia. The cold air sliding down the high Antarctic plateau in fierce blizzards primes the great engine which runs all the weather and current systems of the southern hemisphere. And the Antarctic's icy waters underwrite the very life of Australia's seas, the factory that makes their essential nutrients. The process begins when the sea ice breaks up after the long polar night of winter, and the returning sun stimulates a burst of growth. The warming of the surface waters carries them offshore, and the cold waters well up from the deep. They bring up minerals, which together with the sunlight fuel vast blooms of algae, marine plants that become food for great swarms of tiny crustaceans. Some of the wealth eventually flows through to Australia's seas, after weaving through a complex web of animal life that culminates in large marine mammals, from seals to whales. Most seals, like this Weddell, hunt fish and squid, but some take penguins too. Surviving here burns up a great deal of energy, yet these penguins catch enough fish and crustaceans to keep their chicks growing strongly in the short summer. The penguins seek safety in numbers. They leave and enter the water together, for leopard seals lurk nearby, waiting to snatch a lone or unwary bird. The wealth of nutrients generated by the Antarctic summer flows into the southern oceans and onto Australia through a complex system of currents. Their origins go back 150 million years, when all the southern continents were locked together. As this great landmass broke apart, the oceans were set moving in new patterns. Australia broke away 45 million years ago and moved north. Antarctica was encircled by cool currents, and the polar south iced over. Where the circumpolar current meets the warmer temperate oceans, There's rich feeding for many seabirds before the cold water sinks, taking its cargoes of nutrients with it. Far below the surface, skimmed by the wandering albatross, that rich water pushes northwards along the ocean floor. The voyage may take 1,000 years, but eventually the currents rise on the slope of Australia's continental shelf and enrich the local waters. The nutrients ferried in all the way from the Antarctic support great forests of kelp and a marvelous diversity of marine life. In more sheltered waters, the corrugated leaves of the string kelp create their own small eddies to extract food from the passing currents. Tiny crustaceans live on and around these towering plants and fall prey to pipefishes and seahorses. Their markings blend in beautifully with the foliage, but in another member of the family, camouflage has evolved to even more wonderful perfection. This bizarre creature has come to resemble a piece torn from the weeds among which it lives. The disguise protects the leafy sea dragon from its enemies, and it's also useful for stalking its own prey of small shrimps. The wealth of food produced in and around the kelp forests supports a great range of animals and varied ways of feeding. The ultimate predators are the sharks, all muscle and teeth. But hunting uses up a great deal of energy, and these grey nurse sharks spend the days resting in deep channels, circling slowly to let the water bring oxygen to their gills. The channels teem with other fish. They're safe for now, but come nightfall, the grey nurses will go on patrol. Fish have many ways to evade the snapping jaws. These leather jackets have poisonous spines, which they erect in the face of danger. Next to survival, the major driving force is reproduction. That presents a special challenge in these turbulent waters, where unprotected eggs are scattered far and wide. Many animals solve the problem by guarding their eggs till the young inside are well developed. For the blue-ringed octopus, the process begins with a remarkable mating. Though among the most venomous of sea creatures, they pose no threat to each other. After a brief struggle, she submits to the probe of an arm modified into the male's sexual organ. With the other arms holding her still, it searches out the female's reproductive passage and finally penetrates it. Now comes the extraordinary part of this strange coupling. The sperm's wrapped in a transparent tube-like package, and he pumps it along a special channel in the arm. Seawater reacts with the sperm and forces it out of the packet into the female egg chamber. After the eggs form, she keeps them within her body's embrace until they hatch into well-developed young octopus. The sea dragons also keep their eggs safe, but in their case, it's the males that do the caring. The youngsters are nurtured in tiny pouches flanking his tail, more than 200 of them. Now they're about to break free, tail first. They're already large enough to escape the legions of predators that eat small things, and well enough developed to swim and fend for themselves. The need to give young a good start in life brings other animals into the coastal waters of southern Australia. From the air, it doesn't seem all that hospitable, yet these are the favoured breeding places of the southern right whales. The water is warmer here than in the sub-Antarctic, where they've spent the summer feeding. And in winter, they come here to mate and give birth. When the whales arrive, they're well fed and ready for courting. And this young bull's on the trail of a likely mate. Much time and energy goes into breeding, and the rituals of courtship and competition often explode into boisterous displays. As well as power and grace, there's tenderness when the gargantuan mothers play with their newborn calves. The close bond between mother and young is essential to its survival, for she provides both food and protection for the first 2 years of its life. When it's born, the calf seeks out the mother's nipples almost immediately. Whale milk is a rich food, and the youngster doubles its weight in the first few weeks. The calf has to grow big and strong quickly, because by the end of winter, it has to follow mother on the long journey back to the polar seas. While the whales make their way south, other marine mammals gather to breed. The Australian fur seals come to a few favoured places, and such a concentration of prey attracts the ocean's fiercest predator, the great white shark. The white pointer is a supremely designed killer. It grows to a streamlined 7 meters, and a battery of detectors homes in on the vibrations and electrical impulses sent out by prey. It relies on speed and surprise, but once the shark's been spotted, a swift and agile seal has no trouble evading the mighty jaws. With sharks patrolling the water, the shore is a safer place to have young. And where the sea breaks the coast into rock ledges and pools, the seals establish their colony. The bulls fight each other for prime sites. The key to breeding success is to have a territory where cows pass by most frequently. The losers end up away from the female traffic, with less chance to breed. Around 5,000 animals jostle for space, and the colony grows by the day, for the cows are now giving birth to the pups conceived the year before. This one's proving a difficult birth, for the pups emerging flippers first. The pup remains partly wrapped in the birth membrane, and the head needs to be freed before it can draw its first breath. While silver gulls squabble over the afterbirth, the cow is intent on her newborn's first attempts at suckling. After a few days, she'll mate again and leave her young to get the feel of the water while she goes back to the sea to feed. When the breeding season ends, so does the need to guard territory, and the bulls too return to the sea. The Southern Ocean brings in the food on which all life here depends, and it is the richness of these waters that gives a special character to the marine life fringing Australia's southern coasts. Paradoxically, the warmer waters to Australia's north provide far fewer nutrients, and that's given rise to a very different marine world. About 20 million years ago, Australia's northward drift took it into tropical latitudes. As the continent thrust its way towards the equator, islands rose, diverting some of the equatorial currents along the eastern coast of Australia. With the currents came new forms of life, among them the seeds of new types of mangroves. Mangroves are trees that tolerate salt water and can grow in mud devoid of oxygen. To obtain that vital gas, the mangroves raise their roots from the mud to expose them to the air at low tide. The tangled roots trap the rich silt carried down by the rivers, and whelks and mud creepers sift through it for microscopic particles of food. While the tide is out, armies of soldier crabs march across the flats. Unlike other crabs, which scuttle sideways, soldiers move forwards, scooping up silt for their mouthparts to filter. The rising water warns the soldiers to burrow into the mud and escape the predators coming in on the flood tide. At high water, the tidal forest provides rich pickings for many animals. Sea urchins move onto the mangrove roots and scrape the algae with their sharp beaks. This jellyfish has algae actually growing within its tissue. It lives upside down to expose them to the sunlight and so produce energy. The mangrove roots become anchoring points for even stranger creatures. They look like lumps of rock, but they are in fact living corals, animals encased in limestone. This might well be how the first corals colonized Australian waters 18 million years ago. Sunlight is essential to the coral's growth. The clearer the water, the more limestone they produce, enough eventually to make mighty reefs. The reefs grow and die with the rise and fall of the seas. The latest growth began only 8,000 years ago, yet it's created the greatest series of reefs on Earth. The Great Barrier Reef stretches for more than 2,000 kilometers along the coast of northeastern Australia. It's the power of the sun that enables this enormous living structure to flourish in waters that are almost deserts. As well, the whole system is designed to make the most of what little the sea does provide. It begins with the outer edge, shaped to absorb the power of the waves and to channel the few precious nutrients carried in. The frontline corals and fish get first call on the fresh supplies, and this is where there's the strongest growth, the most diversity, and the fiercest turbulence. The tides flow through the gutters to the rest of the reef, ferrying not only nutrients, but also the ingredients for the limestone that binds the corals into reefs. In the calmer waters of the back reef, corals fan out into staghorns and huge plates to catch as much sunlight as possible. More than 2,000 kinds of fish live here, each forging its own lifestyle. The fish are the most conspicuous, but the reefs harbor myriads of other creatures and a myriad ways of finding food. This little porcelain crab lives within the shelter of an anemone, and its mouth parts have become modified into a delicate net to catch food floating by. Nearby, another crab crops the seaweeds growing on its shell. The seaweeds, the algae, are the reef's primary producers. They convert the nutrients carried in by the tides into food for many animals. Some damselfish even garden their own patch of algae and weed out less tasty plants to promote the growth of their favorites. Butterfly fishes have different mouth shapes, each tailored to a particular kind of food. Some have flattened mouths to pinch the fleshy tips off these rounded types of coral, while long snouts can probe into crevices for tiny crustaceans. While corals are eaten by many creatures, they themselves are predators too. The tentacles are put out by the coral polyps, each a single animal, together a mighty colony. Their deadly arms are tipped with stinging cells to pierce and paralyze any small creature that floats within reach. The water's thick with these microscopic animals, the plankton. Once stung, there's no escape, and the tentacles pass the victim to the polyp's mouth. Plankton only supplies a little of the energy corals need to make their limestone. Sunlight provides the rest. To harness the sun's power, corals enter a remarkable partnership with minute plants which live inside the coral tissue. The plants produce oxygen and carbon for the coral to build into limestone and get their own nourishment from the waste. The more sun they get, the faster corals grow. But too much sun can be fatal. Very low tides leave some reef tops exposed, and the corals that live here have a kind of suntan lotion in their tissues to screen out the deadly ultraviolet rays. They also secrete a mucus to stop them drying out. When the tide returns, the mucus is washed away and becomes part of the food supplies ferried by the currents. The reefs form an almost self-sustaining society in which everything is recycled and nothing goes to waste. It's crowded with life, yet it's an ordered world in which color and pattern are the language of both survival and reproduction. Color warns other creatures that this nudibranch is poisonous. And the sea slug's coat of vivid leaves is loaded with evil-tasting glands. Color serves as camouflage to blend the lionfish into the coral rock. And color plays its part in breeding. It sorts out who's who and signals readiness. Among these small fish, it's the males that prepare the nests. This one's leading a potential mate down to the place he's got ready. She lays down strings of transparent eggs. He follows with his sperm to cover them. And in the days that follow, he'll protect them from the reef's many hungry mouths. Once they hatch, the young are usually on their own, but not so the offspring of this black and white damsel. It guards its brood like a hen its chicks until they've outgrown some of their enemies. But eggs are also sought after, and there are as many ways to protect them as there are fish on the reef. The stinging tentacles of the anemone give clownfish ready-made protection. Males and females pair up for life, and they work together to prepare the nest site. The male dances attendance while his larger mate lays her golden brood. Then he sheds his sperm over them. After an hour or so, the female makes her last pass, and 400 eggs are waiting to hatch. From now on, the male will tend the brood and get rid of any infected or infertile eggs. Among the cardinal fish, male care goes a remarkable step further. It's his mouth that becomes the nest. The pair swim side by side. Then suddenly, she releases her eggs in a sticky ball. For a moment it hangs while his sperm covers them. Then he takes it into his mouth, not to eat, but to incubate. Occasionally he half spits the eggs out, but only to have the water supply fresh oxygen. There are obvious drawbacks to a mouthful of eggs, and pipefish have come up with another solution. Their mating dance is the prelude to a male pregnancy that's even more astonishing. The dance serves to synchronize the reproductive cycle. By the time the partners rise into the water, the female's sexual organ has become clearly visible. Finally, with a motion so swift it almost defeats the eye, she sweeps a sheet of eggs into the pouch on the male's belly. Now the dance changes to a wiggle. The male presses his pouch against his partner's body to settle the eggs securely in place. Out on the sandy flats, more robust rituals. Triggerfish males put their breeding effort into building large nests and keeping rivals away. The powerful mouth shifts lumps of coral rubble into a pile to form an egg chamber, and he blows the sand away so the eggs will have a clean surface to stick to. The chamber's at the center of a hole he's dug out. It's saucer-shaped and several meters across. The sand keeps washing back and constantly needs to be scooped out again. But at least one eye is always kept out for trespassers. Small fish may eat the eventual eggs, but it's the appearance of a rival male that provokes the most aggressive response. It's now the entire nesting domain that's at stake. Hours of mouth-to-mouth combat leave the lips in shreds, but a final charge sends the intruder into retreat. When the moon is in the first quarter, females arrive high above the breeding colony, and each male tries to lure as many as he can to inspect his nest. With so many to choose from, she can afford to be particular. and it takes all his powers of persuasion to lead her down. But the decision remains hers, and he won't know until the next dawn whether she'll choose his nest to lay her eggs. As it turns out, she does. Daylight reveals a cluster of eggs. While her mate keeps watch, she'll tend them till they hatch that night. The life of the reef is ruled by the sun and tides. Many creatures time their breeding so their eggs hatch at night and disperse on the outgoing tide. There are fewer hungry mouths about then. The daytime fish prepare for sleep, some in cocoons of their own making. Soon after dusk, 10 days after the eggs were laid onto his body, the male pipefish goes into labor. Some of the hatchlings begin to emerge from his pouch. Though tiny and transparent, they're well developed. With a vigorous shake, he releases the rest of his brood. The eggs of the triggerfish are also stirring in their coral nest. Moments later, the hatchlings burst free, all together, so their numbers will confuse any predators. By daylight, the currents have carried the larvae far away from the reef, out to the relative safety of the open sea. Now other fishes are preparing to spawn, gathering in a channel on the outer reef where the water flows most strongly. They too tune their breeding to the tides, but in a very different way. Instead of guarding their eggs till they hatch, these parrotfish will release them directly into the water. To prepare for that moment, the older males mark out territories to court females and fight off rivals. The battle is brief, for time is short. The tide is turning, and a female needs to be found before the rush to spawn. There's a stir. Moments later, there's a sudden dash high up into the water where the current flows the fastest. The fish eject their eggs and sperm like puffs of white smoke to mingle and fertilize. Schools of fusiliers dart in to feast on the spawn before it disperses. But there's so much that most of the eggs escape on the tide. Every ebb tide in summer carries out great quantities of eggs and larvae to hatch and grow in the vastness of the open ocean. Sheer numbers are the key to success, for even away from the reef, there's risk. Whale sharks cruise these waters. At up to 18 meters long and weighing 15 tons, they are the largest fish in the sea. Their bulk is sustained by the plankton swept into the cavernous mouth. Plankton, of which fish eggs and larvae often make up the larger part. The manta ray is another specialized plankton feeder. Its head has become modified into a twin scoop. Despite their vast appetite, it's not these giants that pose the greatest threat, but the risk of starvation. For the open ocean is like a desert and has little food for growing young fish. Occasionally, the currents come to the aid of some small fry, and they find shelter and food within the fronds of jellyfish. Of the myriads sent out to sea, only a few will survive to be carried back to the reef and replenish their kind. Sometimes chance favors a species, and the larvae have found more food or suffered less predation. For a time, that species dominates its patch of reef. The assortment of fishes is an ever-changing kaleidoscope. Some fish increase their chances by having their young look like something else. This juvenile resembles a distasteful flatworm, nothing like the tasty batfish it'll be when it grows up. Flowing through all the different ways of reproducing are the tides and the currents. The flow is especially important to the corals themselves, for they can't go in search of partners. The water becomes their go-between in a spectacle that has no rival on Earth. In November, when the water's warm, a few nights after the full moon, the corals of the Great Barrier Reef prepare to give birth. Up and down the length of the Great Reef, eggs and sperm wrapped together in tiny bundles are pushed out through billions of coral mouths. Corals many hundreds of kilometers apart spawn almost simultaneously. A mass ejaculation cued by the moon and the temperature of the water. Nearly every kind of coral joins in. Most have the female and male cells wrapped together. Some polyps are single sex and release clouds of either sperm or eggs. For a few hours, the coral seas are aswirl with blizzards of sex cells. Long worms come snaking through the clouds to join in the synchronized frenzy to spawn. Their bodies are strings of eggs and sperm that peel off and join the throng. There are hungry mouths too, but the sheer volume ensures that enough eggs and sperm reach the surface to fertilize. The packages break up once they're near the surface, and the sperms are set free to seek eggs of their own species. Somehow, possibly following a trail of chemical clues, the minute sperms manage to find the right eggs. They burrow inside, and minutes later, the fertilized egg cells begin to divide. Soon, a coral larva takes shape, still only a millimeter or so long. Yet from these tiny beginnings, mighty reefs grow. But there is no birth and growth without decay and destruction, on the reef as elsewhere. Among the more visible destroyers are the hump-headed parrotfish. Their teeth have become fused into strong shearing blades that bite off whole chunks of coral. They grind the coral into a paste, extract the living tissue, and void the sandy waste in curtains through the water. Waves and currents mold the coral sand, and in places begin to heap it up, eventually to emerge above the water as coral cays. Some of the islands become the beachhead for a remarkable invasion from oceans far away. Early in December, giant green turtles appear in the approaches to the island. Massive animals of 1/4 of a ton and a meter across. Most are females, heavy with eggs. Their ancestors have been roaming the seas for 100 million years. The seas have changed, shores have come and gone, but the turtle's breeding continues in its ancient pattern. In this summer of peak numbers, 10,000 turtles come ashore here every night, and space is at a premium. Each turtle's urge concerns only its own offspring, and some dig their nests where other clutches have already been buried, indifferent to the fate of those earlier broods. Many eggs are destroyed, and wrenched prematurely from their nests, the early hatchlings are left with little chance. Because the baby turtles are scattered so randomly, the rufous night herons can take their pick. Dawn finds the turtle legions making their slow way back to the sea. But it's low tide, and they're left all but stranded on the reef flat. It'll be mid-morning before the returning tide comes to their rescue. Some of the older, weaker ones barely make it to the water's edge. some perish soon after they get there, and as the tide rises, it carries away the casualties. It's what the tiger sharks have been waiting for. They seldom attack healthy turtles, but scavenge disabled and dead ones. The scent of blood brings other sharks, and the water churns with a frenzy of snapping jaws. With their jaws underneath, the sharks have to turn upside down to get a grip, but it doesn't make the butchering any the less efficient. While the sharks feed, the new generation of turtles stirs in the sand. About 6 weeks after the eggs were laid and the mothers departed, the hatchlings greet the world. This time, if the breakout goes to plan, the entire brood bursts out together to overwhelm the waiting predators. An instinctive tendency to make for where the sky is brightest will take the hatchlings to the sea. Most will make it, for such an abundance of food confounds the herons. Where they go, no one knows. They vanish into the vastness of the ocean, as they've done since long before Australia became a continent. When they reach breeding age, in 40 years, some will return, riding the tides and currents that govern all the life of the sea, and ultimately that of the plants and animals on the island continent itself.